Okay, so guys, now in this video we have to do another proof question which says that x is equal to a cos cube theta and y is equal to b sin cube theta, and we have to prove a dy by dx plus b tangent theta. Now, a few things. This is the given portion of the question and this is the thing which we have to prove, okay? And so let me just separate this thing, a cos cube theta and y is equal to b sine cube theta. We can see that we have to introduce a derivative into the question, but before introducing the derivative, we know that we have to use our given terms for reaching this conclusion. So how can we utilize these terms for reaching the derivative? Of course, we can take the derivative of these terms, okay? But the problem is that there is a third variable. Okay, so these are basically the parametric equations, and if they are the parametric equations, they can be solved only using the chain rule. So how are they parametric equation? Because we can see that we have x, we have y, so these are the two variables, but then we have the third variable theta. So if there are more than two variables, then it is a parametric equation, and then you have to utilize the chain rule. And a and b are constants, so we do not have to worry about them. Now let's just apply the differentials. So our chain rule would be basically, we have to introduce dy by dx, right? So our chain rule would be dy by dx would be equal to dy by d theta dot d theta by dx. So this would be our chain rule, that first of all we have to find the derivative of y with respect to theta. That would be very simple, y by theta d theta b sine cube theta, and then the derivative of theta with respect to x. Now this is actually a bit complicated because over here we have x, okay, and if we take the derivative, the theta would be in the denominator, so we have d by d theta a cos cube theta. Now you see, this is a bit complicated. We will find dx by d theta, but the chain rule is saying that you have to put in d theta by dx. So at the end of the process, we will reciprocate the equation, okay? So now let's just proceed. B is a constant, so it would be separated, b d by d theta sine cube theta, then b, so it is a power, so the power rule will be obeyed, d by dx fx power n, so the power would be at the beginning, then the function, and the power minus 1. So power, then the function, the power minus 1, 3 minus 1 is actually 2, and now the derivative of the angle. What is the angle? The angle is anything which is present under the power. So if we consider fx power n, then fx is the angle. So over here we have sine cube theta. So cube is the power, then the function would be sine theta. So d by d theta sine theta, okay? So we have b 3 sine square theta multiplied by the derivative of sine theta is actually cos theta. So this would be our final derivative, 3b sine square theta dot cos theta, okay? Then we have dx by d theta. So if we see, a is again a constant, so we will just separate it, and d by d theta cos cube theta, again the power rule will be obeyed, a the power 3 will be at the beginning, then the function cos theta power minus 1, 3 minus 1 is 2, and then the derivative of the angle, sorry, it would be theta, so cos theta. Now the angle is theta, so a 3 cos square theta multiplied by the derivative of cos theta is actually negative sine theta, okay? So we have 3a cos square theta multiplied by sine theta, and I think we should keep the negative sign at the beginning. So let's utilize our chain rule, dy by dx is equal to dy by d theta dot d theta by dx. So dy by d theta is actually 3b sine square theta dot cos theta, and d theta by dx is this thing, but we have to reciprocate it. So we have 1 divided by negative 3a cos square theta multiplied by sine theta. So sine theta would be cancelled by sine power 1. Of course, we have sine square theta and we have sine theta, so only one power will be cancelled. Then we have cos square theta, same thing. Then we have 3 would be cancelled by 3, so we are left with sine theta, okay, divided by cos theta, okay, then the negative sign, and then b over a. Now this arrangement is actually very specific, because if you see, we have negative sine theta by cos theta, it would be negative tangent theta b divided by a dy by dx. Now what was our original question? The question says that we have to prove a dy by dx plus b tangent theta. So I think this question is actually proved. We just have to arrange some things, some variables, and we will be good to go. So dy by dx, we can see that a is actually present with this derivative, so let's just move this a towards the left hand side of the equation. So if I multiply it by a and multiply by a on both sides, so a will be cancelled and we are left with a over here. Then we have negative tangent theta multiplied by b. So the question actually says that you have to move this tangent theta toward the opposite side of the equation so it becomes positive. Over here we have it negative. I will add tangent theta b on both sides of the equation plus tangent theta b. This would be cancelled and we have a dy by dx plus b tangent theta would be equal to 0. So you can see this is the final proof.